Morning, dear students. Today we will start a new topic. It is called logarithm. This logarithm is linked with the indices. Okay, if your concept of indices is clear, then you can easily understand the topic logarithm. So here you see, suppose we fix a number 2. Suppose we fix a number 2 and we raise to the power 2 is 2. What is the answer? 4. Again, suppose 2 to the power 3. What is the answer? 8. Again, suppose 2 to the power 4. What is the answer? 16. It is known to us. Clear? Now, in the definition of logarithm, I am coming the definition little bit later. So here see, in the definition of logarithm, what they have told that the power, this exponent are the logarithm of this number. Here base is what? 2. Base of the logarithm should also be 2. And how we write it? This power 2 equal to logarithm, in short we write log, L-O-G, log of the number 4, and base is what? 2. We write like this. Similarly, what? Exponent is what? 3 is equal to log. Then little bit a small gap is there, space, a. Then base is what? 2. This is the writing style of logarithm. Similarly, this 4 equal to log, then 16, base is what? 2. Alright, now I am coming to the definition of log. The definition is said that let, or you can write if, a to the power x equal to b, where a is a positive real number and a not equal to 1. A is positive real number, means a is greater than 0 in the number line, and provided a cannot be equal to 1, and x is a rational number, b also greater than 0, then x is called the logarithm of the number b. Logarithm of the number b. WRT stands for with respect to the base. Okay. Logarithm of the number b with respect to base a. That means here base of the power is what? A. This expression base is what? A. In logarithm also its base will be a. Number is what? Will be b. Alright? Now how to write this? So mathematically a to the power x equal to b implies x equal to x is called, this exponent x is called logarithm, means we write log of the number b, keep a space b, then base is a, write like this. Okay, so a to the power x equal to b, so this exponent equal to log b, here base is a, so base of the log will also be a, and writing style of log is like this. Clear? Now this process is converse also. Converse of this is also true. That is, conversely, if suppose log b base a equal to x, then if you remove this log, then these two numbers will interchange. Base will remain in its place, base a to the power, it seems a to the power b equal to x. If you just ignore this log here, it seems that a to the power b equal to x. Is not it? Now while you remove log, then these two numbers will shift. A will be in its place as base. So a to the power x will be equal to. I hope you have understood it. Now let us learn some formulae related to log. Formula number 1. A to the power log x base a, answer is x. What I have written, a to the power log x, how to pronunciate it? Log x base a. Don't read as log base a then x. Okay, it should be log x base a or log x to the base a. We can write. We can read like this. So the entire expression we have to read like this: a to the power log x to the base a. Answer will be what? X. Now you have to see, if the base of the expression, entire expression, and base of the logarithm is same, then this part will vanish. This will be the answer. Number 2, log of m into n base a equal to log m base a plus log n base a. Number 3, log of m by n base a equal to log m base a minus log n base a. Okay, then number 4, log m to the power n base a equal to n log m base a. What happens here in this case? How to read this? Log of m to the power n to the base a is equal to n into multiplier n into log of m base a. Okay, so proof of this formula are there, we will do it afterwards. Then number 5, log of a base a equal to 1. Same, log of a base a to the base a is what? 1. Moreover, it is known to us base of a logarithm should always be positive. Base cannot be equal to 1. Remember this. Number 6, log of a base b equal to 1 upon log b base a. Log of a base b equal to 1 upon log b base a. Alright, so this is called reciprocal formula. Okay, this is the reciprocal formula of log. Then next, number 7, log of a base b equal to log a base c into log c base b. This is called change of base. This is change of base formula. Okay, log of a base b equal to, here you see we have changed the base. Base was b. Forcibly we have changed the base as c. To adjust it, what to do? Then here c base b. C will go cancel. We will have a base b again. Okay. Then number 8. Log of a base b. This one also you can write like this. Log of a base x by log b base x for any base. For any base x. Any means what? Base of the logarithm cannot be 1. Base cannot be negative. That one is not. Apart from 1 and negative number, you can choose any base. Okay. Then number 9, log of a to the power m and in the base is b to the power m. Log of a to the power m, base is b to the power m. So its answer is what? M by n. These two exponents here, number is what? A to the power m, base is what? B to the power n. Two exponents of the number and base are what? M and n. So this m by n will be, this fraction will become the multiplier of log. Log, then a base b will be there. A base b. Okay. Next, number 10. Log. Remember this, if we do not mention any base while writing the log, it is implied that the base is considered to be 10. Okay, base will be considered 10, 10 if base is not mentioned in the logarithm. Okay, so log 1, answer is what? 0. Then log 10 is what? 1. Log 100, base should be 10 here. In this case, base is not mentioned, means what? Base is 10. Log 100 equal to 2, etc. In this way it will continue. Log 1000 will be what? Log 1000 will be 3. Log 1000 will be what? 3. Is that it? Now let me cite some examples how to find the logarithm of a number with respect to a given base. Okay. So suppose now formula is not yet. Some examples. Number 1, say log, it is required to find the value of log 64 and base is what? 2. Base is given 2 and logarithm of the number is what? 64. It is required to find the value of this. So what you will do, equal to log. In two methods we can do. I am showing both the methods. Here see 2 and 64 is a larger number. If the question is given in this way, 64 larger number, try to take the prime factor of the number, greater number. So 64, if you take the prime factor, 232, then 216, then 28, then 24, then 22. So how many to 1, 2, 3, 4, 5, 6. So 64 we can write 2 to the power 6. Alright? Now this equal to, now apply the formula number 4. Fourth formula. 4 number formula. So this power will come forward into log 2 base 2. Okay, this power will be shifted here. So log 6 into 2 base 2. Now 6 into log a base a, answer is what? 1. So 6 into 1 is what? 6. This is the answer. Okay, this means what? 2 to the power 6 equal to 64. We know this. So 2 to the power 6 equal to 64. So by definition of logarithm, what? 6 is called logarithm of the number 64 to the base 2. Just to match this with the definition, whether this comes or not. Okay. Now second method. Log 64 base 2. Let log 64 base 2 equal to x. Suppose we don't know the value of this. So we are assuming let log 64 base 2 equal to x. Now what will we do? Here this implies we are going to remove the log. So from definition what we have got, this will be 2 to the power x equal to 64. Is not it? I told earlier that if you remove this log, then this 64 and x, this will be interchanged. So 2 to the power base will be in the base, 2 to the power x will be equal to 62. Now this implies, you see, 2 to the power x. 64 means what? 64 is 2 to the power 6. Now bases are same, powers can be compared. So x equal to 64. What is x? Therefore log 64 base 2 equal to what? 6. Clear? So 6 is called the logarithm of 64 with respect to base 2. Alright? Clear, my dear? So herewith today I am finishing today's lecture and demonstration also. Now you please take down these sums, these formulae in your copy. Next day we will do the proof of the formula. Okay? I hope you have understood the topic logarithm. So that's all for today. Thank you.